and I will welcome you for the today's session on the types of firewall. So in the last session we had discussed about the few concepts on the types of firewalls. So today let us continue that. So before continuing that, so however I said, however we say there are four basic types of the firewalls which we are dealing. So those are packet filtering, application level gateway, and also a stateful inspection, and finally the circuit level gateway. So among these four, so we had discussed about the two types of firewalls in the last session. So that you can uh, you can find it as yeah, you can find that. So in the last session, we had discussed about this. So you can, those who are not there in the last session, you can find that in that lecture in the video, which is available in the YouTube as two types, which is packet filtering routers and also the stateful inspection firewalls, what we discussed in the previous session. So today we are going to continue for the further another two types. So that will take up for today's session. Okay. So today let us take up the next two types of firewalls. So those are the application level gateway and also the circuit level gateway, which are left out, which are not covered in the last session. So before I continue, anyone respond? So does my PPT are visible and my audio is, my voice is audible?
Yes, sir.
Okay, let us continue. So with the all this packet filtering and also the stateful inspection, what we dealt in the last class till here. So today let us take up the application level gateway. Remember this application level gateway and also the next one which we are going to take up the circuit level gateway. Both will be happening at the gateway level, which is higher than your router. So remember, so whenever you want to have a multiple communications between your device and the outside network, so whenever it is happening, that firewalling process, that is what filtering process or checking process, which is going to happen in the gateway. So that is what one of the kind it is application level gateway. Even the other way, you can also tell you in the other way that as this is what application level gateway, so which is something like the process which is happening at the application layer, so which is at the application specific, user application specific. So here it doesn't bother about like what type of connectivity and all. So it's only bother about what type of application, for which application you are getting the request, or for which kind of particular specific application you are getting the incoming request, that has to be verified. And where you are verifying at the gateway, so which is application level gateway. So we say it as this is what the application level gateway, which will be inbuilt with the multiple protocols which is at the application layer level. So either it can telnet, ftp, smtp, hdp, it can be any protocols which are available at the application layer of your tcp ip. So those, so because the communication may be happening with respect to the telnet application, or it can be FTP or mailing purpose, or it can be client server, like that, based on the specific application. I repeat, based on the specific application. Because in the last sessions, whatever we deal in with respect to packet filtering, I said that that is going to happen between the network layer to the transport layer, or in the other way you can say internet layer to the transport layer. There you will never bother, or the filter will never bother what is the purpose of the packet, what is the purpose of the incoming packet. It only bothers that does that packet is going to satisfy the set of rules which are already defined or not. And those rules also only deals about the addresses. So from where it is coming from to where it is going to. So it can be with respect to the IP address and the port address. Even in case of stateful also we saw that. So we only deal about the connectivity. So which connection, which incoming connection, so did you establish the secured connection or not, like that. So you didn't bother about the specific application oriented. that you do deal in this application level gateway. So here you not only bother about the actual data, you also bother about what is the purpose of incoming packet. Based on that also you can make a classification. So in that perspective itself, here the four protocols which are defined here, which is the telnet, which is for remote calling, I mean say that's what you say, a remote connectivity. Then again we have file transfer protocol, mailing purpose, then again client server communication, like that. For what purpose you are getting that incoming packet or incoming request, that is to be classified. That is going to happen at the application level. That's what we say, based on the specific application. And as it is happening with respect to the application level, and very importantly at the gateway, so it may also act as a server, and that is which is that you call as a proxy server. So which is something hallucinating server, which actually bothers about, or before the request is delivered to the actual server, so that decision will be taken care by this application level gateway. So as the decision is already taken in this application level gateway, so it can also be called as one of the type of server, which is a proxy server. And what its purpose, its only purpose is something like it has to bother about the traffic which will be which you will be getting at the application level, a specific application level. So what you will be getting, you will be getting the multiple requests, you will be getting the multiple requests from the user. So that has to be validated at the proxy server. So then you make a decision as usual, whether the request has to be sent back or it has to be returned to the user. So all this, remember the last point is very important. Everything whatever it is happening, everything will be stored in the log file, or in the other way say that auditing file. That is available to the user. So that complete logistics, are in other way say that a statistics of the decision making or the incoming data, everything, the complete details will be stored in your log file or audit file, which will be applicable or which will be available to the user. So then moving, so this is what a depiction you can observe right here. So with respect to this, you can observe clearly where you are bothering at the application layer. So you will be bothering about at the application layer, because you doesn't have that's what I repeat again and again. So till the transport layer, you only bother, see, in the transport layer you bothered about connectivity, whether it is a TCP connection or the UDP connection. Again, whether it is with respect to process communication, you also made use of which input port, which output port. And in the internet layer, you bothered about which is the actual source, which is the actual destination by using the IP address, like that. So till the transport layer, you don't bother about, or it won't concern with the what purpose the transmission is actually happening for. Whereas that is going to happen only in the application level. What is the purpose of the data transmission? So this application level gateway has the um, classification or the filtering process or the firewalling process in the application layer, based on the application, based on the purpose. So that is what your application level gateway. So that kind of filtering process or scrutinizing process will happen on the application level based on incoming traffic. So then what are the advantages and disadvantages? So obviously this is higher security than packet filters. Because why this is higher security than packet filters? In the sense, per suppose if there is a incoming packet, even that packet may pass through all the constraints given at the packet filtering. I hope in the last session we saw packet filtering constraints are something like, which is the IP address, which is the port number, what is the channel, all that. Whereas, so as the what is exactly it is there inside the packet, that you don't know in the that cannot be seen and that cannot be visible in the packet filtering. So but that can be visible and that can be made a decision in the application level gateway. So in what I am saying, in a normal way, let me tell you something like, in the packet filtering, you only made sure that, or the security fellow only made sure that where he has come from, where is the address, what is his name, everything he made sure, everything is perfect. But you doesn't know, or the security person doesn't know what is the harmful behavior or harmful kind of maturity he has in his mind. That is what is the purpose he had come for. That kind of decision you can't make it in the packet filtering. but that will be done in the application level, because at the application level itself, you will get to know what is the purpose of incoming packet, what is the specific use of incoming packet. So that kind of decision making, or that kind of filtering can also happen with the application level. So only it is higher security than the packet filtering. Then again, so it only needs scrutinizing the only based on the allowable application. That's what so it means to say that, so the packet filtering is already taken care in the interfacing between the internet layer to the transport layer. So that's what first level of filtering is already done. Now at the application layer, application layer, you will get the packets only with the specific application or a specific purpose. That's what we say allowable application. Those only you need to scrutinize, and those you need to verify. So that's what one more a simplicity or a simple advantage. Last thing is, as already said, if whatever it is happening at the application level, everything which is a complete logistics or the complete auditing data will be available as a available for the incoming traffic for the user. Whereas there is a disadvantage as well, which is additional processing for the gateway. So because the gateway may be performing only for the connectivity for the devices between the end nodes to the outside world. So in such case, you'll be using the gateways. So now if you want to apply this application level firewall in the gateway, so that is something like you'll be increasing the functionality of that gateway. So that's only the disadvantage of this application level firewall, which is applied in the gateway or the any end node for your network. This is what application level gateway. uh, that's next firewalling. Yeah, any doubts in this before I go to the next, because it's a very simple thing which I explained. Okay, if there are no doubts, then we'll move on to the next last type of gateway, which is circuit level gateway. So here you can see this circuit level gateway. So I can say this is an advancement or extension of the application level gateway, because this circuit level gateway here also will be firewalling, which will be happening at the gateway level. So which is, when I say that gateway level, in the sense, obviously it is at the application level itself. Even then, why this circuit level came into the picture, or circuit came into the picture? Why do you call this as a circuit in the sense? So see, in case of application level gateway, we said that for every incoming packet, yes, you do classify based on the specific application. But here in case of circuit, what we are going to do in the sense, if the set of packets are coming for the same application, to the same device, then you don't have to classify, or you don't have to perform the firewalling for each packet, because all those can be belongs to the, or all those are belongs to the same perspective or same application. In such case, those can be linked together, or those can be grouped together, which is what you call as circuit. I hope you may understand even better. And also one more thing you need to understand, something like, it is just like it is, when you are sending in the other way, try to understand what I said in the first case, something like, if even though you are checking for the application, but if you are getting the multiple packets for the same application, in such case, the circuit level says that there is no necessity of checking or verifying each packet which are incoming for the same purpose, because all can be linked together, because all those are for the same application. That's the first. Second thing, so in the other way, you may also say that all those packets or all those data which is incoming for the same device, and that device already tested and the application is already available. In such case, you don't have to perform the verification for each and every packet for the specific application. So that is what the circuit level gateway as a just illustration. Now let me go in depth. So something like circuit level gateway, obviously it is for, which will be applied as a standalone system. It will be applied as a standalone device or standalone system. So where it will be having the set of outside connections and set of inside connection, for which you will be applying this circuit level gateway, which will be acting as a standalone system. So this is where you'll be having a classification, which is the output from which output port you received and to which output port it has to be carried. So that's what, there is a link, there is a circuit between this output ports and the input ports. That is complete thing will be taken care by your circuit level gateway, or which will be applied in the gateway. So that's what, that's only we call it as it's a standalone system. Then obviously it performs all the application which will be performed by the application level gateway. And third point I want you to understand very importantly, it does not perform end to end TCP connection. This is very very important. It does not perform end to end, it does not permit an end to end TCP connection. So what exactly I mean to say in the sense, understand here itself, for this circuit level gateway you might have connected multiple devices. In this example, three devices can, total six devices can be connected, whereas three will should be at the outside connection side and three devices can be at the inside connection side. Whereas when you connect them, you don't have to connect them as a end to end. What I mean to say end to end in the sense, they don't have to be connected directly by a multiple intermediate devices, because that process will be taken care by this circuit level gateway. When it is going to take up the charge, or when it is actually performing, which is circuit level gateway is performing, you don't have to have a end to end TCP connection between the actual outside host to the actual inside host, because it is happening through this circuit level gateway. So what the for this circuit level gateway, how it will be in the sense, it will be something like two connections, one is between outside to the inside, the other between the inside to the outside. So it's something like that. It creates the two this creates the two connections, two TCP connections. One is between this outside host to this circuit level, the one more is between the circuit level gateway to the inside host. I hope you are understanding. Again, let me repeat. So whenever you make use of the circuit level gateway, even though the connectivity is required, but you don't have to, or it will never allow the end-to-end TCP connection. What I meant to say end-to-end TCP connection in the sense, it is a direct connectivity between this outside host to the inside host. But in our scenario, as there is a circuit level gateway between this outside host to the inside host, so this connectivity is not directly between outside to the inside like this. Instead of that, I am saying there two connections are created. Which are those two connections in the sense? That's what, one connection between outside host to the gateway, the one more connection between the gateway to the inside host. These are the two connections I'm talking about, outside connection and inside connection. Like that, two TCP connections are created instead of a single end-to-end connection when you make use of this circuit level gateway. That's what I mean to say. Next, last thing, as I am dealing with the TCP connection, so obviously this complete process is going to taken care with respect to the TCP segments from one side to the other side. That's what TCP level gateway. So here, like an extension depiction, and also you can observe. So for the point, like in which layer actually it works in the sense. Yeah, any queries? Any queries? Okay. So in which layer actually it works in the sense, actually we say that it works between the transport layer to the session layer. So it works between the transport of the session layer. So why does it works based on the transport of the session layer in the sense, at the beginning itself I just said in a normal sentence that when there are the multiple packets or continuous packets for the same application, those need not to be tested in a continuous manner, or all the packets belongs to the same application. No, those need not to be tested. That's what I said at the beginning of the circuit level. Now also I'm saying the same thing in the different way, something like if all those packets are belongs to the same application, are going to receive at the same session, not at the different session, obviously. Because once the session is established for any specific application, then only you will start receiving the packets. So whatever the packets you receive in that session, you will be considered that all those packets will be for the same application. So only this circuit level gateway which will be implied between this transport layer to the session layer, between this. So from the transport layer, or in the transport layer, you can establish the TCP connections. You can establish the TCP connection. That's what I said here. You will be establishing the two TCP connection between the outside to the gateway and gateway to the inside. So that you can do it in the transport layer. That you can't do it in the either internet or the application layer. Then also I said that as you will be dealing with the TCP connection, you also deal with the data in the form of TCP segments. So you will deliver the TCP segments from transport layer to the next layer. But actually in the TCP AP, if you take up the TCP AP, next layer will be application itself. But if you elaborate this application layer in detail, if you remember, application layer itself has a three layers, which is application, presentation, and session. So you have application, presentation, and session layer as same as your OSI. So after this transport layer, above to this transport layer is the session layer. So you will be delivering the TCP segments from the transport layer, which are received through the TCP connection, to the session layer, which is a sublayer of your application layer. So that is where this classification will happen. So only we say it as circuit level gateway, which happens between the transport layer to the session layer, which when you are delivering the TCP segments to the session layer, that is where this TCP or that is where this circuit level gateway filtering will be happening. So that's the circuit level gateway. And it also has a few advantages and disadvantages as well. So then this is the second point. I'm directly going to the second point. This is what I said earlier also. It avoids the filtering of every individual packet. You don't have to bother about every individual packet, because it is bothering with respect to the number of packets belongs to the same application or same session. So it doesn't need to bother about the filtering of each and every individual packet. Then again, obviously, private network data hiding. So it something like, in what way say private network data hiding, in the sense based on the session, whatever the application is initialized, whatever the data being exchanged, that will be grouped together and hidden. So it will not be visible. It will not be, because you will not be dealing as each and every individual piece of that data. You will be dealing it as a whole data. That's what this private network data hiding. Next, flexible in developing address schemes. So see, in what way this flexible in developing address schemes, in the sense, because you doesn't bother about, I'm talking about the circuit level gateway. The circuit level gateway doesn't bother about from which node it is coming from, or from which port address it is coming from. It only bother about, so once the TCP segments are received, then the classification has to happen at the session layer. Then we have this is the fourth point. Again, it is a very important for you guys to remember. Something like, it doesn't need any separate proxy server for each application. Whereas if you remembered, in the application level here, you need the application, for the application you need a proxy server. You need the proxy server right here in the application level gateway for each application. Whereas here you don't have to have a separate proxy server for each application. That is the very important advantage of CLG. That's what circuit level gateway when you compare to the application level gateway. Whereas it also has the few disadvantages. It also has few disadvantages. Something like, it can work with the app, I mean, say it cannot work with the active content. What do I mean to say this active content? So in the what I mean to say active content, in the sense, so whenever you'll be receiving data, so I mean, so whenever you will be receiving the incoming request in the form of TCP segments, those has to be scanned. So whenever you will be scanning, per suppose if it has a data in that request. So try to understand my point. So because no, the segments are the any packet you talk about. So there will be at the time of transmission, there will be a signals, something like, the control signals and the data signals. Whenever you talk about the transmission, also data transmission and control transmission. So whenever you are dealing with the um, control transmission or control signal transmission, there you can apply this. So That's what, whenever you are dealing with the actual data transmission, when you will be dealing with the actual data transmission with the TCP segments, so that TCP, whatever the TCP segment will be transferring, obviously that TCP segment will be having its own TCP header. In that TCP header, based on the acknowledgement number, for every sequence number will be having, based on that it will make a decision whether it is a control segment or it is a data segment. Because if it is a data segment, then obviously your acknowledgement number should be next number compared to your sequence number. So based on that, it is going to make a decision, and those cannot be handled by using this CLG, which is circuit level gateway. And next is, whatever the CLG what we have only for this TCP connections only. Even when I was explaining, I said the TCP connection itself. But there are the few proposals which are being for UDP connections as well. That's what connectionless services also. But as of now, it is not implemented or implied. Then last is that TCP/IP stacks are mandatory to be modified for using the CL gateways. Why this TCP/IP stacks are mandatorily modified in the sense? So whenever you talk about the TCP/IP in the sense, those may not be configured the session layer particularly. So because session layer will be inbuilt with the application layer whenever you talk about just a TCP/IP stack. But if you want to apply the circuit level gateway, as already said, which has to be it has to taken care of the work in the actual session layer. But if you simply say that just a TCP/IP stack which may not be implemented, or which may not be configured the session layer individually or particularly. But if at all, if you want to apply this circuit level gateway, you should have the session layer as a specific configuration should be made for the session layer. So that is required mandatorily. That is required whenever you want to apply this a circuit level gateway. So that's the one more disadvantage. Yeah. So that's what those are what the two types of firewalls what we studied today. So application level gateway firewall and also the circuit level gateway firewall. So those are the end of the four types of firewalls what we studied in the last session and the today's session. Yeah, guys, any doubts in any of these four? Hello.
No doubt, sir.
Yeah, guys, again I'm asking again, if you guys have any doubts, you can let me know.